Hello dear viewers, welcome to my tutorial video. In this session, I am going to show you how you can create a PID program for Mitsubishi Q series PLC to operate a level control loop. In this video, you will go through the process of creating PID program, simulate this PID program with the factory input-output software and integrate this PID control program with the wincc SCADA system to visualize the level control parameters. Our main issue in this video is to show the process for creating PID program for Q series Mitsubishi PLC and simulate this PID program with the factory input-output software. Next time, we will develop a PID program for Q series PLC to implement the real-time pressure control. The PID control program instruction shown in this video will be used to implement PID control for Mitsubishi Q series, L series and QNS series PLC. To implement the PID control for this series of Mitsubishi PLC, there have been a set of sequence program instructions, and I will show you how this set of instruction can be used to develop a complete PID program. In this video, we will create a PID program to control the liquid level of a tank of 300 cm height. The tank is equipped with a level measuring sensor which measures the tank height from 0 to 300 cm and makes 0 to 10 volt DC signal, and a control valve which opens from 0 to 100% depending on the voltage signal from 0 to 10 volt DC. The PID simulation program receives the existing tank level as process value, required tank level as set value, and depending on the set value and the process value, the PID program makes manipulated value for operating the control valve. If we look at the processing method for PID control, we see that the PID operation is executed by the generating manipulated value or output depending on the set value provided by the user and the process value which comes from the measurement of the existing process parameter value. From the Q series PLC PID instruction manual, the algorithm behind the generating manipulated value can be found as following algorithm shown in this video. So, you will find a set of PID control data and input-output data that have to be taken into consideration while you are implementing PID control using PID control instruction. Note that when the PLC executes the PID control program, the PLC receives the set value and process value in the range from 0 to 2000 digital value and makes manipulated value in the digital value range from 0 to 2000. That is, the PLC processes the set value, process value and manipulated value in the digital value range from 0 to 2000. Though PLC processes set value, process value and manipulated value in the digital format, a human operator always access this input-output parameter in the form of physical unit. That is, the physical unit for set value and process value of the level process station is 0 to 300 cm and for manipulated value is 0 to 100%. So, the physical value range must be converted to 0 to 2000 digital value range when the PID program implement this PID operation. For setting the PID constant value, follow this instruction which suggests constant setting value in the given specified range stated in this PID manual. While programming, you have to set the data memory address for PID control data and input-output data which will be used in the PID program. So, to set the data memory address for PID control data, follow this instruction manual. Here, the set of data memory address is provided for control data if you want to implement on PID control loop. To set the address number, just specify the number for first control data. Then, the address for other control data will be automatically specified according to ordering provided in this manual. So, if you set the data memory number D500 for the control data number of loops, then the data memory register for other control data will be D501, 502, 503 and so on. The same procedure will be applicable when specifying the data memory for PID input-output data. So, if you specify the data register number as D600 for the first input-output data, then the data register for other input-output data will be D601, 602, 603 and so on. Now, let's proceed to create PID program for the Mitsubishi Q series PLC. Go for GXORX2 programming software and double click to open this. First, we have to create a new project for the Mitsubishi Q series PLC. We have come to this kind of window here after creating new project. As we create the PID program and run this PID program with the simulated PLC, we do not need to add any analog or digital input-output card or do not need to make any hardware configuration in this program. We just proceed to create the PID program in this programming window. We can start on the PID program by first writing a sequence instruction which will set the starting or initiating data register number as D500 for storing the values of PID control data. So, for initiating the data register number as D500, the instruction will be according to this instruction, the data register number for all PID control parameters will start from this number D500. According to the PID control manual, if you want to set the value for the first PID control parameter, that is the number of loop, the data register number for this parameter will be D500. We will implement one PID control loop in this project. So the value for this control parameter will be on and write the instruction as depending on the order for numbering the data register address for PID control parameter, the instructions for setting the required values for the PID control parameters have been written as you are looking in this window. Proceed to next line of instruction. Here, for setting the data register number for PID input-output parameter, this line of instruction have been written where the initiating or starting data register number have been set as D600. Next line of instruction have been written to keep the PID operation running. Now write the instruction for setting the value for PID input-output parameter. One of the input-output parameter is setting the auto manual function for the PID controller. If we follow the ordering number for input-output addressing, the number for data register address for this parameter will be D615. So, for switching between the auto mode and the manual mode of the PID controller, write the instruction as That is, if the value for data register address D615 is set to 0, the controller will act in the auto mode, and if the value is set to 1, the controller will act in the manual mode. Now, to access the PID, set value, process value and the manipulated value from the SCADA interface, we can write this instruction in the another part of the program. So, from the program option in the navigation bar, add another part of the program. In this part of the program, we will write the instruction to access the set value, process value and the manipulated value. Note that the PID program processes set value, process value and the manipulated value in the digital form from 0 to 2000. But when we access this parameter for monitoring or controlling, we have to access this parameter in the form of physical unit. So we will write the instruction in this program which will convert this parameter from physical value to digital value when we will input this parameter in the physical unit, or convert from digital value to physical value when we read or monitor this PID parameter in the physical unit. So these are the instructions written to perform all types of necessary conversion. The converted parameter value in physical unit have been stored in a set of data register. For example, the digital value range for process value have been converted to process value range in the form of physical unit, which is 0 to 300 cm, and the converted digital value have been stored in the data register D224. In the same way, instruction for conversion of set value and the manipulated value have been written in this part of the program. Finally, one more programming part have been added to write the instruction to simulate this PID program with the factory input-output software. As this PID program is for simulation purpose, no analog input or output card have been used, but virtually there is a level sensor in the level control loop which gives 0 to 10 volt DC signal, and there is a control valve which is operated from 0 to 10 volt DC signal. So, to feed the sensor signal as process value for the PID program in the digital form 0 to 2000, and to deliver the manipulated value 0 to 2000 as control signal for the control valve, this part of the PID program have been written. Now writing for PID instruction is almost done. As the PID program is divided into 3 parts, we have to send these 3 parts of this PID program to the program setting. So go for parameter tab. Under the parameter tab, double click on the PLC parameter to get the window for Q parameter settings. From the program tab, insert the part of this program into the program setting. When inserting the part of this program into the program settings finished, click on the In button to finish the settings for the PLC parameter. The later programming for PID control have been almost done. Now proceed to run this PID program with the Mitsubishi PLC simulator. Go for Debug menu and click on the Start Stop Simulation. The PID program is downloading to the GX Simulator 2 software. The downloading for this PID program have been finished. Now click on the Close button to start the PID operation. The PID operation is running now. Go for the instruction for controller mode of operation. Here the data register value for controller mode have been set to 0. This means that the controller is running in the automatic mode. So go for set value option and put a value in the data register 240 as set value for the PID control program. The set value for this PID control program have been set to 40. Note that the controller manipulated value or output value are changing so that the process value reaches near to the set value. So this PID program is working properly to control a process. Now to understand the PID operation completely, we have to run this PID program with a level process station which will be found in the factory input output software. But this PID program cannot exchange the input output data with the level process station of the factory input output software. So for interfacing this PID input output data with the input output data of the level process station, this input output data will be converted into OPC format. This can be done using the OPC tags in the Mitsubishi OPC server software. Now for creating the OPC tags for the input output data of the PID program, go for MX OPC configurator software and double click to open this. In this window, at first we have to add the Mitsubishi PLC simulator as a device. So from the address space, click on the new MX device, open the configure tab, select the PC side interface as GX simulator 2, put the CPU series as Q CPU, click on the next button and finish this for creating the new device. Now close this window and click on the save button to save this new device. You can put this device name as PID. So a new device have been added to this software. Now it's the time to add or create the OPC tags for the input output data of the PID program. So double click this device, right click and click on the new data tag. The first tag we are creating for the set value. So put the name as set value and the input output address or data register address as D240, as we have used this address in the PID program for the set value. Put the data type as real type and click on the save button to finish for creating the OPC tags for set value. Similarly, all the OPC tags for the other input-output data of the PID program have been created that you are looking in this window now. Go to PID program in the Mitsubishi GX Auto programming software and run the Mitsubishi PLC simulator from the debug menu in the menu bar. The PID program is running now with this Mitsubishi PLC simulator. Go to Mitsubishi OPC server and turn on the monitoring option to check whether these OPC tags are enabled to get the data from the input-output parameter of the PID program that is running in the Mitsubishi PLC simulator. Now, put a value in the OPC tags for set value. Note that the other input-output data of the PID program are changing their values that you are monitoring through these OPC tags. Now we want to control a level process station with this PID program in the factory input-output software. The PID program will exchange the input-output data with the level process station through these OPC tags. Using these OPC tags, the PID program will get the process value from the level sensor and the manipulated value of the PID program will be transferred to the control valve to open or close it. Now go for factory input-output software and we will see how to configure the factory input-output software with the Mitsubishi OPC server. Open the factory input-output software. Go for new button and create a new project. From the palette window, drag and drop the level process station to this working space. Now we have to add the drivers for the Mitsubishi OPC server. So from the file menu, click on the driver option and select the driver as OPC client DAUA. Go for configuration tab and select the OPC server as which is running on this PC now. Click on the browse button. Now go back to driver for the OPC server. Here all the tags have been appeared in this driver that already have been created in the Mitsubishi OPC server. Now add the input-output device of the level process station to this OPC tags. Now go back to level process station. Go for OPC server software and double click on the PID device to show the OPC tags. Turn on the monitoring option. Now put a value in the OPC tag for set value. The parameter of the PID program are changing. Now go to Factory Input Output Software. Note that the field bulb is open, which is getting the data from the PID program through the OPC tags. Connection have been established between the PID program in the Mitsubishi PLC simulator and the factory input output software. Finally, a graphical interface has been created in the wincc SCADA system to make visualization for the PID control of the level process station. We will now perform PID operation for the level process station from the runtime condition of this SCADA interface and monitor PID input-output parameter. So this is the video where the working procedure for PID program of Mitsubishi Q series PLC have been shown in details. If you find this video informative and helpful for you, please like, share and make comments on this video, and don't forget to subscribe this channel.